and Telecommunication Engineering Division Board IEI, Dr. H. O. Thackeray, President IEI, Dr. G. Ranganath, Chairman Committee for Advancement of Technology and Engineering IEI, and our worthy key speakers, Dr. Ruthvi Si Joshi, Associate Professor and Head, EC Department, Parul University, Gujarat, and Dr. Jagdish Kumar Monla Rathore, Associate Dean and Professor, COE, Electromagnetics and Antenna Research Center, Birla Vishwakarma Mahavidyalaya Engineering College, Vallabh Vidyanagar, Gujarat, and the participants of this event. Dr. Jagtar Singh, sir.
Thank you, Manpreet. Respected Dr. H. O. Thackeray, President, Institution of Engineers, India, Dr. G. Ranganath, Chairman, Committee for Advancement of Technology and Engineering, Professor Dr. Girish, Chairman, Electronics and Telecommunication Engineering Division Board, Dr. Tara Singh Kamal, former Chairman, Electronics and Telecommunication Engineering Division Board, Engineer J.S. Deol, Honorary Secretary, Bathinda Local Center, Corporate Members, IEI Executive Members of Bathinda Local Center, Faculty Members, Scientists, Students, Ladies and Gentlemen, good evening to all. It is my proud privilege to extend a cordial welcome to Honorable Dr. H. O. Thackeray, President, Institution of Engineers, India. I would like to take opportunity to welcome Dr. G. Ranganath, Chairman, Committee for Advancement of Technology and Engineering, Institution of Engineers, India. Thank you, sir, for guiding us and extending privilege by accepting our invitation to join this event. Your brilliant ideas, unconventional thinking, and daring engagements are appealing and constructive. Thank you for your determination and efforts for the growth of Institution of Engineers India. We are sure that your guidance is bound to take Institution of Engineers to new heights and glory. On the behalf of IEI Local Center Bathinda and the participants, I thank you, Dr. Ranganath, Chairman Kate. I would like to take opportunity to welcome Professor Dr. Girish, Chairman, Electronics and Telecommunication Engineering Division Board, Institution of Engineers, India. Thank you, sir, for giving permission for conducting this webinar. I would like to take the opportunity to welcome Professor Dr. Tara Singh Kamal, Chairman, Electronics and Telecommunication Engineering Division Board, IEI. Dear sir, I want to extend my gratitude to you, sir. Your positivity continues to inspire us every day. This positivity gives us energy and direction to work even harder and better. Thank you for guiding Dr. Tara Singh Kamal, us, and extending the privilege by accepting our invitation to join this event. I would like to take the opportunity to welcome and thank today's expert, Dr. R. Ruthvi Si Joshi, Associate Professor, Head Electronics and Communication Engineering Department, PIT, Parul University, Vadodara, Gujarat, and Dr. Jagdish Kumar Mohanlal Rathore, Associate Professor and Dean, College of Engineering, Electromagnetics and Antenna Research Center, Birla Institute, Gujarat. We are really honored by your esteemed presence today that you have agreed to share the valuable experience with us. We will definitely be benefited from your talk. I want to congratulate Engineer J.S. Deol, Honorary Secretary, IEI Local Center Bathinda, and Manpreet Kaur, Assistant Professor, ECA, and their team for organizing this event. I wish you all the best Nevertheless, I want to extend my greeting to esteemed corporate members of Institution of Engineers India, executive members of Bathinda Committee, faculty members of Yadavindra College of Engineering, scientists, officers, students for joining this event through the webcast from various parts of India. Thank you all. Thank you.
Thank you very much, Jagtar Singh sir, for the warm welcome address. Now I request Dr. Girish Sirikisan Mundada, Chairman, Electronics and Telecommunication Engineering Board, IEI, to address our delegates and participants. Dr. Girish sir, please.
Thank you. Respected President in absentia, Dr. Hemant Thakre sir, our KATE Chairman, my mentor, my big brother, Dr. G. Ranganath sir, past ETDB Chair and veteran Council Member of IEI, Dr. T.S. Kamal sir, Convener of the program, Professor Dr. Jagtar Singh, who also happened to be the ETDB member, Secretary of the host center, committee members, invited speakers, and all those who are attending this webinar. First of all, I congratulate Bathinda Local Center for being very active in arranging such programs. They are the one who perhaps carry this technical flagship for IEI and ultimately for ETDB. I wish them to continue this spirit and arrange such programs at least monthly once, and all the programs as per suggestion will be approved, and we hope many good things, many good topics to come up. Truly speaking, I have forgotten about this program, and I thank Dr. Rangnath sir who called me up, and he wanted link to be shared with him so that he can join. But in fact, his call helped me to join in time because submissions were going on. It slipped off and I was about to miss. But thank to all such people around me who helped me to get in time. So really, I cannot express the feeling which I have at this time, that how I have joined this program. I have not prepared anything for, and then I had to just look for a link. So thank you, Dr. Ranganath sir, and Dr. T.S. Kamal, who always keep on guiding us. And we expect you, sir, to guide to our board so that we can scale good programs and we can come out with recommendations that subsequently we can be taken up for annual technical journal and our publication. Yeah, thank you, Kamal sir. And the topic which you have chosen is very important and will help many young graduates to go forward in their career in their PG and PhD programs. So while they work, we expect them to put their publication, their work into our journal, into our conferences. So many of the IEI members will get benefited. And I'm sure the deliberation, the recommendation coming out of this webinar will help us to navigate our path further for the future. So thank you all who have shaped this webinar. Thank you all the speakers. Thank you all IEI authorities who help us get necessary approval and programs then can be arranged. And I also want to thank our Assistant Director Technical Engineer Sudhir Chakravarti, who put the things in place and work as a bridge between the host center and ETDB board. So thank you one and all for shaping this webinar, and I wish best to the program. Thank you.
Thank you very much, sir, for this warm address. Now I request Dr. Hemant Thakre, President IEI, for the presidential address.
No, Manpreet Kaur Madam is not there.
Okay, sir. Okay, sir. So now I request Dr. G. Ranganath, sir, Chairman, Committee for Advancement of Technology and Engineering, IEI, to formally address the participants. Sir, please.
Thank you, Manpreet Kaur, for active participation as a moderator.
Yes, sir.
It's a good beginning.
Okay, thank you, sir.
The President of IEI, Dr. Thakre, two brothers today in the program who are absolutely with me in the council, being their academicians. One is Dr. Girish Mundada, Chairman of ETDC Board. Then Dr. Jagtar Singh Ji, he is also academician, the Chairman of. Then Dr. E.S. Diol, Secretary of the Optical Center. Dr. Kamal Saab, putting to you particularly. And even speakers, academic, Gujarat, Dr. Ruthvi Si Joshi Ji, Dr. Jagdish Kumar Mohanlal Ji, all the committee members of Patna Local Center, headquarters staff, Director Technical in charge, Sudhir Chakravarti, who has shown a good interest in attending these programs. All the participants, because nearly 60 participants are already registered, they are there in online attending this program. My evening greetings to all of you. I am so happy. Patna Local Center always keep on moving in technical activities, technical activities, because I am there in the council for the past about 5 years. I keep on observing, and after Jagtar Singh has taken a chairman of Batenda, till programs have become more active. They are doing a lot of active programs. And our pandemic situation teaches us to make the entire globe is very small in communication, in going for these webinars as well as seminars. Anyway, this year we already opened the doors for seminars. We conduct good number of webinars, no doubt in that we will wish you. But at the same time, I appeal to chairman and honorary secretary and committee members to come forward to have at least a 2-day all India level seminars and national conferences in different divisions, if it is possible, this year of 2022. I am very happy to give approval, double happy to encourage, double happy to be with all of you when you are doing a good activities like this. And as Chairman ETDB was telling, the topic of today, even our moderators are telling nicely, optical system for advanced wireless communication. Already communication is very effective today in the world. That's why it has become very small to all of us. One part of the globe to other part of the globe, we can pass the communication within no time, which is not there if we take about 2 decades back or 3 decades back. I can recall my student life. If you want to communicate anything to parents, we need not less than a week in sending a communication through postal. Otherwise, at least we need half an hour to 1 hour to stand in telephone to communicate. Today it's a fraction of seconds in social media, either WhatsApp or Twitter or Facebook or so on. And even nook and corner of the country, people are having one set to be called as mobile, where they can pass communication very effectively. But now, this wireless communication, till you want to make it advanced, because there's no end for our technology. So technology is having a big challenges, and you are going like anything. And of course, biggest advantage is there with this. Only thing is, all this advanced technology is to reach a common man in the entire world. Then only it is going to be useful for our technology upgradation. But certainly, today 2 speakers, those are eminent academicians, they are going to give a lot of inputs for all the participants. Participants is going to feel double happy in getting this benefit. My heartfelt wishes to enter center and see the Kamal Saab being is one of the senior-most citizen. Generally, I used to call him affectionately a citizen of council members, because his contribution, his commitment, his age to speak. I used to call him even till today. Kamal Saab is available means I used to hug him as my elder brother. That is my affection to him. Kamal Saab, very happy to see you. Thank you to see you. My wishes, my prayer to Almighty to make you to reach century in your age and to bless all of us. With this, I have to ask excuse of Jagtar Singh Ji and Mundada Ji, because I had attended another one program at 5:45. I will not be in a position to listen to the speakers. I may be unlucky. Otherwise, my wishes will be there. With this, let me thank our moderator. Let me thank the chairman of Jagtar Singh Ji, who is my affectionate brother in academic side, affectionate brother in council, and my Mundada is in all. He already endorsed. I am an elder brother to him, but he is my affectionate brother to him, not elder or younger. Affectionate brother to him, a family member to me. With this, let me wish all of you good luck and let this program will have a better success and big success. So thank you all.
Thank you very much, sir, for this warm address. Now I am going to invite our first key speaker of this webinar, Dr. Ruthvi Si Joshi. Before that, I would like to give a brief introduction about the first key speaker. Dr. Joshi is a head and associate professor in the Department of Electronics and Communication Engineering at PIET Paru University, Gujarat. He has completed his PhD in Electronics and Communication Engineering from Sardar Patel University, Vallabh Vidyanagar in 2014 and Master Degree in Electronics and Communication from Dharam Desai University, Nanded in 2005. He has a total academic experience of around 16 years. Mr. Joshi has also been awarded with certificate for exceptional contribution as Nodal Center Head from the Ministry of Education, Innovation Cell and AICT, as well as certificate for mentoring the student project at Chhatra Vishwakarma Award, AICT Delhi. He has guided 15 students for their master thesis. At present, 5 students are doing PhD under his supervision. Moreover, he has published large number of research papers in national and international journals. His research interest includes wireless communication systems, wireless ad hoc and sensor networking protocols, software-defined radio-based smart communication system design, FPGA-based digital designs, and VLSI designs. Now I request Joshi sir to please start your talk. Joshi sir, please.
Am I audible?
Yes, sir, you audible.
Just a minute, Joshi sir. Manpreet madam.
Yes, sir.
Just 3 of our council members are part here who are attending this webinar. One is Dr. Bhaskar Bhandarkar sir, who always attend all the ETDB programs. Our ETDB member Brahma Reddy sir and Dr. Suresh Challa. They are attending this program. We acknowledge their presence and we welcome to this seminar.
Okay, sir.
Thank you. Yes, you can carry on. Joshi sir, sorry for keeping you awaiting.
It's all right.
So your slides are visible. It is okay.
Is it visible, ma'am?
Yes, sir. They're visible.
So, good evening, everyone. Thank you very much for providing me the opportunity to deliver and talk on pixel webinar on the optical system.
So you can make it a full screen, sir. The slide.
Yeah, sir, yeah.
The slide mode. Yes, sir.
Is it so? Now it is
Yes,
visible?
yeah.
So I'm thankful to all the officials of Institute of Engineers, the Untitled Chapter, the moderators, the Dr. for providing the opportunity to deliver and talk on how the multiple access technique for next generation wireless communications. So before starting my presentation, I would like to provide just a brief outline of my presentation. I am going to discuss why 5G is required. Next generation wireless communication system, that means we consider it as a 5. Only cellular communication is not in a focus, but the IoT networks, vehicle-to-vehicle communication, and many other things need to be considered. Then how to improve the performance of 5G. And as a part of that, I'm going to discuss one of the advanced technology that can be used to improve the performance of 5th generation wireless communication. It's a non-orthogonal multiple access technique. Then how Noma works, that we are going to discuss in the outline. What kind of advantages we are going to get when we are using the non-orthogonal multiple access technique compared to over DNS network techniques. What kind of types are available? This topic can be helpful to the researchers those who are pursuing their PhD in the same area. We are working on the improvement of fifth generation or next generation wireless networks and the research issues related. So, first of all, what is 5G? So, we all know generally when the generation is changing in cellular communication. Otherwise, when generation is changing like 2G to 3G, 3G to 4G, 4G to 5G when we consider, so that means always we are considering that it's related to the mobile communication or cellular communication. But 5G technology, the fifth generation wireless communication system, is not only applicable to cellular, but it is applicable to some other applications also where actually industry required, like industrial IoT required very high speed communication system. That's why very high speed means we require that kind of infrastructure which can provide very fast services so that the not only communication but control also can be possible to the wireless network. So 5G is the breakthrough in that part. The next generation of telecommunication network, and they start hitting the market in 2018. First of all, the South Korea has started that. Now here, beyond the speed improvement, the 5G is expected to unleash a massive IoT. So that means Internet of Things now it's everybody is knowing that, and everywhere the application of IoTs you can find. So in that IoT, if we want to improve the speed or increase the speed of that particular network, then what kind of enhancement or improvement we can do? So
Sir,
massive
your
IoT,
voice is very low. Please keep your mic near
is
to
it
the
so?
mouth.
Now am I audible properly?
Yes, yes, now it is. Keep your mic near to the mouth, please.
All right. So the beyond the speed improvement in fifth generation, actually, it is targeting the massive IoT also. Massive IoT is nothing but one ecosystem where network can serve communication needs for billions of connected devices. That means when your network is scalable and the number of users increases, or in case of users, if machine is also involved as a part of network, machines, different vehicles, different sensors, all these networks whenever connected. So it is creating ultimately one massive IoT network. And in massive IoT, sharing the bandwidth is very difficult. If limited bandwidth is available, then having the high speed communication is very difficult. So 5G is providing ultimately solution for that. These are the requirements, otherwise it is expectations from the fifth generation wireless communication system. Initially, I'm going to just discuss the 5G related the important features, and then after this, how 5G improvement can be possible. And for that, I'm going to discuss the non-orthogonal multiple access system. So here the first requirements is the speed improvement. Data rate required to be 10 Gbps, which is nothing but 10 times or 100 times higher than the fourth generation and 4.5 generation wireless networks. And 1 millisecond latency is another expectation from the fifth generation. Within a millisecond, the networks with the calls, otherwise communication should be established between any devices. 1000 times higher bandwidth per unit area. This is another requirement of fifth generation. Now, all these requirements are targeting of various applications. Right? Speed improvement is not only the speed improvement requirement is only not from the cellular communication, but it is the requirement from Internet of Things network, IoT networks, ultra wideband communication systems, and many other communication systems, which is which require very high-speed communication. So the fourth requirement is 100 times more number of connected devices per unit area in 4G LTE system. So compared to 4G, 100 times more devices can be connected in 5G. Then 100% availability. That means every time, whenever you call, 100% your call can be, this call can be connected or communication can be established without any kind of rejection of the calls. 100% coverage. That is, none of the corner in the world which you can consider as a dead zone in everywhere network can be available. That way, the 5G communication can establish some small cell networks or highly dense networks so that every corner of the world can be connected to the network. 90% reduction in network energy. The battery power is very important in cellular communication as well as in wireless communication, because in wireless communication, all the devices, transmitter, receiver, all are nothing but battery operated. So energy is very important factor. We can say energy as well as bandwidth. Both the parameters are nothing but the main resources of any communication system. We need to utilize it optimally so that the network can work for a longer time without any kind of issue. So 90% reduction in network energy. This is one of the criteria. Overall network energy, and the last one is up to 10-year battery life for low power IoT devices. You know, the sensor networks, whenever we deploy somewhere, so sensor always or sensor based network be required on that type of places where humans cannot frequently visit that place. So it should be power efficient so that it can work without much issues, and replacement of battery is not required frequently, so that that particular system should be power efficient. So goal of 5G network is that it can provide the high speed communication, because when these are trying to create a high speed communication, so there is a trade off always. When we try to improve speed, the battery power consumption, otherwise power consumption also may increase. That's why, to balance that, the fifth generation communication system involves that kind of strategy where the power consumption is optimal, and that's why the batteries can work. Nowadays, a lot of the efficient batteries are available, or in the battery science, a lot of advancements are there. So we know the batteries generally, we can have that kind of batteries also, which can work for a month, for 2 months continuously. So now, by using this kind of network, wherever IoT devices are consuming less power compared to our mobile phone, that's why we can expect that it can work for 6 months, 7 months generally. But this network of fifth generation network can provide the improvement and that battery life also. That means it consumes very, very less power compared to the normal network or the estimate communication system. So 10 years is the target. It's not like that it's achieved, but 10 years battery life for low power IoT device is the target for the fifth generation. So these are the ultimately these are various expectations from fifth generation wireless communication, and for that, a lot of different technologies and researchers are working on it to improve the performance of fifth generation. Now let us quickly discuss the application of fifth generation. So as initially I told, that fifth generation mobile communication or wireless communication system is not targeting only cellular or mobile communication, but it is targeting or it is designed for various other applications also. So the first application of fifth generation wireless communication system is for industrial applications, where sensors and actuators are connected and they are communicating to each other. Second very promising application of fifth generation communication is driverless car, where the engine means that particular automobile system can take decisions very fast and can take various actions from the signals coming from various sensors. In healthcare monitoring, now you know, since all of you have heard that surgeries and other things can be possible through robotic mechanism. no need to have a doctors involved in that particular surgery, only through the robotic mechanism. So that robotic mechanism required very high-speed communication, obviously. For that, you require that kind of infrastructure which can provide you reliable, robust, and high-speed communication. So this fifth generation can provide this. So in healthcare monitoring, like from remote place, if doctor wants to monitor any patient, they want to just check their vital parameters from the different sensors, and then after now a lot of technology, advanced technologies are available. From the sensors data, some systems can just diagnose the different kinds of disease, normal disease in the patient. So in healthcare monitoring, it is helpful. Then in drones and robotics application, it may be helpful. Then vehicle to vehicle communication, right? V2X, V2 every means vehicle to everything, that means it is V2X. And V2V is nothing but the vehicle to vehicle, and V2I is nothing but vehicle to infrastructure. So all these communication systems required very high speed, and that's why fifth generation may provide that facility. The autonomous car, automatic connected cars, in virtual reality gaming applications, remote surgical operations, simultaneous translating. Simultaneous translating is also one of the promising applications. Like when the person is visiting any foreign or any other country, so obviously that person is not having much idea about the language of that. So simultaneous translating, that means real-time translation can be possible. When I am speaking right now in any language, it can be converted to any other language quickly in a real time. And all these things require very high-speed communication. So these are the major applications of fifth generation wireless communication. Now, how to achieve this? What are the ways to, what is the magic behind fifth generation? The fifth generation, what happened in fifth generation wireless communication, so that you can achieve this much speed, and whatever applications just in the previous slides we have discussed, how all these applications can work with that particular wireless communication system. So first of all, small cell networks. Small cell networks is one of the way. The cellular network, cell that means here, cell that means a radio coverage area under the one mobile tower or base station tower. You can call it as a cell. So the generally coverage area of any mobile tower is 1 kilometer, 2 kilometer. So if you can imagine that if in your city or in your town, if you have 100 mobile towers and you can provide the services to 20,000 users or 30,000 users or 1 lakh users. Now, if the number of antennas or number of the base station towers increases, that means cell size reduces. One mobile tower can cover small area only, and then after the another tower means there which can provide the radio coverage area. So if you have small cell network, then definitely the capacity improvement is there, speed improvement, all these things can be possible. So one of the way is small cell network. We'll discuss it with the graphical presentation. Let me complete just listing of this particular method. Then relay stations we can use. Relay stations, that means not a direct communication, but hope to hope. That means if I want to send my data from one place to another place, so I'm not directly communicating, but I'm sending it through multiple repeaters. So you can call it as a relay station. So I'm sending, if I want to send X to Z, then I'm going to send from X to Y and then from Y to Z. So Y is nothing but a repeater between X to Z. X to Z direct communication is also possible, but it is long distance, so consume more power, and the reliability is also very less. And that's why rather than sending the data directly, we can use hope-to-hope communication. So relay station is one of the options. Massive MIMO is very emerging technology. A lot of researchers are working on it. Massive MIMO, that means it is multiple input, multiple output, or multiple antenna system, where in place of one antenna, you can use hundreds of antennas, massive number of antennas you are using. That's why it's called as a multiple input, multiple output system. Then beamforming antenna patterns, like whatever antenna we are using, if we are using a particular type of antenna which can provide us a directive radiation pattern, then we may improve the capacity, we can reduce the interference, and the high-speed communication can be possible. And this is very advantageous and you can say very efficient technique using millimeter waves. Many of you have heard this ultra-wide communication. So ultra-wide communication provides communication between the devices in a short range but very high speed. That means within a or in an indoor communication system within a building, if you want to send or receive any signals with very high data rate, so at that time millimeter waves, otherwise you can use very high frequency, which is in the bandwidth of that frequency range very high. That's why it is ultra wideband we can call it. Then cognitive radio is the another method which you can use to improve the performance of fifth generation wireless communication. I hope, am I audible to all of you properly? Am I audible properly?
No, sir. Audio is disturbing in between.
No, some disturbances are there. Dr. T.S. Kamal, his mic is on. So it's creating some kind of noise. Can somebody inform me? All right. Otherwise, my voice is audible to all of you?
Yes,
Okay.
you are audible.
So here, the cognitive radio, then generally as a modulation technique from 2G to 3G, when called 3G to 4G, we are having advancements in modulation technique also. So in fifth generation, rather than using the frequency based or the phase based modulation, rather than that, spatial modulation can be used. The spatial modulation can provide very good efficiency with reference to bandwidth as well as with reference to power consumption. As we have already discussed, one of the objective of fifth generation is to reduce the power consumption, that means to improve the battery life. So not only the just infrastructure based, but in the process also, or in the processing also, if modulation technique is power efficient, then 5G can provide good communication speed with the less power consumption. So spatial modulation is one of the technique, and the last one where the talk is focused on non-orthogonal multiple access technique. Generally, we are using frequency division multiple access, time division multiple access, port division multiple access. So, and OFDM is nowadays in the NIMO system, it is there. So OFDM system can have certain limitations. So to overcome that limitation, non-orthogonal multiple access techniques can be utilized, where the function wise, the OFDM definitely can provide you very good efficiency with reference to bandwidth. But if you involve the Noma also, non-orthogonal multiple access, then it may improve the bandwidth as well as it may improve the power efficiency also. So these are the ways that what we have discussed, that how 5G is creating or just improving energy efficiency in this system, right? This is the thumb rule, energy efficiency is equal to the spectral efficiency divided by transmission power plus circuit power. So if you are improving the energy efficiency, so energy efficiency cannot be improved through only particular, but spectral efficiency also you need to improve. So this is the thumb rule and the relation between the energy efficiency and the spectral efficiency. The 5G communication system can work generally by using two ways. One, by using my massive MIMO system, and second, small cell network. Small cell network, that is, you can see in the diagram. In the diagram, you can see all the towers are very much nearer to each other. Tower number 1, tower number 2, 3, even on the buildings also, on the houses, on various organizations. The number of towers are there. That means they can have each and every person, otherwise each and every house or multiple houses can have their own base station tower. And they are providing the coverage up to certain distance only, limited distance only. In this way, we may create the highly dense network where a lot of towers are there in the small geographical area, and each and every tower is providing a short coverage. That's why power consumption is also less in a per tower, and whatever mobile devices are there in that particular area, they also require less power because only short distances are there. Maybe 500 meter, 600 meter distance is there maximum between the mobile tower and the mobile phone. So small cell network can use. In a small cell network, there is some limits. You can improve or you can just decrease the distance between two towers up to certain level only. But then after, you cannot more dense network you cannot create, and that's why you can go for massive MIMO system. In massive MIMO system, you can see one tower, only one tower you are using. You are not using multiple towers, but one tower. But tower contain so many antennas. Generally, hundreds of antennas are there. That's why it is called as a massive MIMO system. Now, there may be a question like, how is it possible? If hundreds antenna you are using on the same tower, then there is a chances of interference between them. So how is it possible? So here some beam forming or some kind of strategies are involved. And that's why each and every antenna is just radiating in one of the direction. And that's why definitely some interference is there. But this interference may not create much problem. And all these antennas are sending their information. That's why a lot of parallel communication is going on. And that's why high-speed communication can be possible. Right? It's like MIMO system is generally, if you have single input, single output system, CISO, so only one antenna for transmission, one antenna for reception. So you can say you have one hand only for sending the data and one hand for receiving the data. But if you are using MIMO, so MIMO, that means it is multiple input, multiple output. There are multiple antennas for transmission. That means you have multiple hands for transmitting your data. So definitely you can have fast communication possible in that case. These are the and limitations of the small cell network. First, see, as we have discussed, we may try for small scale SCN, and if SCN is saturated, then we may go for the massive MIMO. So advantage, what are the advantages of small cell network? It can increase the capacity. It can have lower delay because towers are very nearer to each other. When mobile and towers are nearer to each other. A better building coverage, better cell edge coverage. That means everywhere network is available. There is less chances that any corner left or can create can have the dead zone where signal is not available. But when you are having small cell network, that means towers are nearer, so definitely you may have interference, the security issues, the coverage and performance prediction problem, the mobility when the person is moving from one cell to another cell. So at that time, handoff is required, and a lot of other things to be involved, and that's why your MSC can be overburdened if the cell coverage area is very short. So as a can say the to just overcome the drawback, we may use the massive MIMO system, which can improve the data rate, enhance the reliability, improve the energy efficiency in the system, and a lot of the other advantages you can get, which is not mentioned over here, like the when you have energy efficiency, so the battery power management can become very easy in this case. Now, what are the limitations? So here, real-time implementation is very challenging. Right? It's whenever improvement you are doing in different things. So definitely, real-time implementation is the biggest challenge. The theoretically or logically, philosophy we can just provide, but whenever actual implementation is going on, at that time only the real-time problems you can face, and means you can just have idea that what kind of real-time problems are there. So to overcome that, you need to work and you need to research on it. So power consumption is again the more, because a lot of antennas are there, all will consume the power. More hardware requirements you have, and it is sensitive to detrimental effects. So here the detrimental effects is, you can say, where over a time the system may not, or the system performance cannot remain intact or as it is, and that's why you need to, means you cannot have the robust mechanism in the system. So these are the ways, like two ways we have discussed. In 5G, small cell networks can be used and massive MIMO system can be used. Small cell network, once saturated, then we may go for the massive MIMO system. And now the another method in 5th generation, which is focusing on non-orthogonal multiple access technique. So in Noma, actually the Noma technique is not implemented anywhere. Still, it is under experiments only. But it's a promising technique. If the proper hardware, otherwise something can be designed through controller or processor, then definitely this system may provide us very good efficiency in the case of with reference to frequency. Generally, what we are considering that code division multiple access is the best multiple access technique, which can provide us very good capacity. But Noma is also comparable to that. It is competent technique which you can involve for the multiple access. Say here the diagram is explaining the complete thing. Like here, this is the orthogonal multiple, this normal multiple access technique, where generally you can consider our multiple access techniques are generally divided. Means standard one is frequency division multiple access, time division multiple access, code division multiple access. So whatever reference we are considering, frequency, time, code, we are dividing. If frequency division, then frequency we are dividing in, like if this is the whole frequency, then so we are dividing it into this frequency into various bands. This pink color, blue color, yellow color, green color, all these colors are ultimately showing the division. So we may divide the available resources, time, code, or frequency in various slots in orthogonal multiple access. But in non-orthogonal, here you can see OMA, in orthogonal multiple access, power remain as it is. Power is constant here. You can see whatever slots you are creating, frequency division or time division, but the power remains same. But here you are working with power. That means if you are using a particular frequency F1, so F1 frequency or this particular channel is divided in two power levels, power level number 1 and power level number 2. One power level P1 is very much greater than P2, otherwise P2 is very much greater than P1. So there is a clear cut. You can have 50-50 also, but see that you can change as per your requirement. Here you can see in the first diagram, second diagram here. Here in this diagram, you can see the power is divided in two parts, 50-50. In second channel, it is divided unevenly. Here, 3 users data. Here you can see this particular power level signal can be used by user number 1 and another can be used by user number 2. So in this case, 2 users can share this frequency. Here also 2 users are sharing the frequency. Here 3 users are sharing this 1, 2, and 3, and here 2. So in this way, by considering any, you can say the power variations, 50-50, 10-90, 80-20, 40-60. In this way, you can just divide the power levels into different, the total power level into the different power levels, and the Noma technique works, or the multiple access can be provided. Now, what are the why Noma technique is advantageous, or why Noma need to be preferred compared to the OMA? So here it serves more than one user at the same time and same frequency. Say you know that if you are using frequency division multiple access, or if you use time division multiple access, it is divided in number of time slots. But here in the same time slot at the same channel, you can save or you can serve more number of users by just differentiating them through powers. One user is getting very high power signal, second is getting somewhat lower power level, third is getting lower than that. In this way, the power level is divided in various levels, and according to that you are identifying. That means users power levels here. Right? In generally in cellular communication in 2G earlier means the initially in 2G all the users are identified by their frequency and time slots. Then in third generation, they're identified by the frequency and the codes. And in fourth generation, here we are using orthogonal frequency division multiplexing with the CDMA technology. And in the fifth generation, the advancements are there. The different modulation techniques can be applicable. So here, this is one of the multiple access technique which can be possible here. Through different power levels, we are identifying the different users. But I'm just talking about cellular communication related thing. But the same concept is helpful in some other applications also, not on cellular, but in IoT, in vehicle to vehicle communication, machine to machine communication. In all this communication also, it may help. Noma provides higher spectral efficiency. It overcomes the graphical distribution of the users, what we have in the case of massive MIMO and small cell network. Provide good quality of service to the cell edge users, those who are in orders, like on the edges of every cell, they are also getting good coverage. Now this is the scenario how the system actually works. So you can see this is user number 1 and this is user number 2. So generally when one user is nearer to the tower, here you can see this distance is less compared to this distance. So definitely the power coming from user number 2 is always less because it is long distance communication. So now this concept is helpful, or this concept is applied in the design of non-orthogonal multiplier. In place of identifying users by their frequency, generally we are identifying user by their frequency. One user is using F1 frequency, second is using F2 frequency. But here we are considering power. One user who is far, that particular means you need to have high power communication. Means from the tower you need to send very high power to communicate to far users. So one is having high power and second is having lower power level. So in this way, user number 1, sorry, this is first one is user number 2, which is par 1. So here you can say this user number 2 and this is user number 1. In this way, through power you are identifying. And for that, this is the generalized mathematical representation or mathematical just model where you can see the first user is receiving signal H1 PX1, where X1 is nothing but the input signal coming, H is nothing but the channel response, and P is nothing but the channel power required. So P is the one new parameter added into the model, right? This is the new parameter that added because of power domain. It's a power domain multiple access technique. Noma is nothing but in power domain you are identifying the users. So this is the generalized, otherwise common equation, you know, it is in communication. Received signal Y1 is equal to channel response multiplied by input signal or transmitted signal plus noise. W1 is nothing but, this is nothing but the channel noise present in the system. So user number 1 is represented, or user number 1 received signal Y1 through this, and second is receiving, and it is represented mathematically like Y1 and Y2 in this. Now, the H1 channel state response in one of, because one user is very nearer, this is very nearer user, so that's why the channel is less lossy, it is nearer to the tower, that's why very in a proper way the signal communication can be possible. And in another case, channel response is less, that's why here you can see H1 is greater than H2, the response. And total power available for this system is P1 plus P2. So here, user number 2 is far. That's why it required high power. That's why P2 is greater than P1, because P2, user number 2 is far from the user number 1 from the tower. And that's why you are required. So these are the conditions in the system. Now, if you are detecting the signal directly, there are two type of detections are there: direct detection, and second is here in each and every method. The one is direct detection, second is detection using successive interference cancellation (SIC) method. That means user number 2's data directly going or directly received, and user number 1's data is just received here. Rather than just discussing this equations, let us discuss this equation. Here y1 is equal to this. All of you agree with this? Like h1 p1 x1 plus h1 p2 x2 plus w1 minus. Now this is called as a successive interference cancellation. If user number 1 here, if user number 1 wanted to receive the signal, so user number 1 is not receiving signal of only their own, but it is receiving, because it is nearer to the tower, so it is receiving signal of user number 2 also, because tower has radiated very high power from here, it's a very high power. So this power is received by user number 1 also, because user number 1 is very nearer to the so user number 1 is not receiving only its own signal, but receiving user number 2 signals also. But that signal you have to remove, because you want to just receive signal which is intended to user number 1 sent for the user number 1 only. That's why successive interference cancellation. That means the mobile which is
Hello, sir. Audio is not there. Hello, moderator, can you check with
this particular section.
Now it is audible. Okay, sir. It is audible now.
Is it audible?
Yes, sir, you're audible.
Yeah. Okay. Because here the connection is disconnected and now again connected. All right, my screen is also visible, I hope so. Presentation slide is visible.
So this time your slides are not visible on the screen.
So I need to share
Please
it
check.
again. Now is it so? Is it available?
So now they are visible.
Okay. So I hope this slide we have discussed is covered, or it was disconnected. So here, so let me quickly just repeat the things. So here, successive interference, how the system is working in Noma. So successive interference cancellation methodology is used. That means only one user is getting the signal directly. All other users, user number 2, user number 3, user number 4, or any n number of users, all are receiving signal through successive interference cancellation. That means they have to just cancel out the terms related to the other users and only their own terms. Otherwise, their signal which is intended for that particular user can be considered or can be utilized. So successive interference cancellation is used, and in this way, the system is working. Right, the same thing is just represented over here. Now here you can just compare the graph, and from that you can have the clear idea. If Noma system is used, let us consider first the this graph. In a Noma and in orthogonal multiple access in OMA, the dotted line red color is showing the normal OMA technique, and the black color is showing Noma. So here, when you compare the speed of communication between the transmitter and receiver, the channel performance, if you are using a Noma technique, here it is a linear one. This is the linear graph. If OMA technique is used, but if means non-orthogonal multiple access technique is utilized, then it can make it is non-linear, which you can convert. For example, see why non-linear graph, otherwise this kind of graph is coming, because here the difference between two power levels considered as a 0 dB and 20 dB. That means very vast difference is considered, 0 dB and 20 dB, and that's why between the speed of two users, R1 and R2, they are having this kind of the curve or the nonlinear graph is coming between them. But if we are sharing same power among all the users, right now only two users case considered, but if it is three users, like 10 plus 10, 20 dB power is available, we are just dividing the power 10 dB both the users. Otherwise, three users are there, then we can divide 20 divided by 3, that is 6 point something, 6.2, 6.3 dB to each user. So when we divide the power equally, then we can have in both the cases. So from these two graphs, what we can conclude? So if we are dividing the power equally among all the users, 10 dB we equally divide, then there is no difference between Noma and OMA technique. You are not getting any advantage. But if there is a power difference between the users, that means one user is having high power, user number 1 is using high power, user number 2 is using low power. I mean, this is the difference, 20 dB and 0 dB. If you are having power difference between the users, then we may get the advantage of orthogonal, non-orthogonal multiple access technique. We can get the advantages. We can have improvement in the transmission and reception, both these ways. Right here, the same case is represented in OFDM. Both the users are sharing or having same power and same two different frequencies. At that time, we can have this much speed possibility between the users. R1 can have 3.33 bits per second. Means R1 is nothing but the speed of user number 1. R2 is the data rate of user number 2. But if we use Noma technique, then power consumption also reduces. You can see 1/5 power we require. 4/5 power we need to use for user number 2. So we are dividing power in 5 different parts here. And you can see the speed of communication also increases. So this is the advantage. This is the simulation results which are telling that the non-orthogonal multiple access technique can provide us good speed with a less power. So it can improve the performance of 5th generation communication. Now these are the equations like a modification into the Shannon's equation. If capacity of OMA, when we talk about, and we are just talking about the capacity of non-orthogonal multiple access technique. So at that time, in the case of non-orthogonal multiple access technique, you can see here the W is nothing but providing you the noise related information. The total power by using, when you are just finding the channel capacity almost remain same in both the cases, but with a lower power consumption. Here the power consumption is less and similar capacity you can, or capacity sometimes you can enhance also if you can divide the power in number of levels. Now, these are the different non-orthogonal multiple access techniques which can be utilized with the blue color, whatever you can see here below. These are the conventional techniques that we all know, and we have studied so many literature on this particular type, like FDMA, TDMA, CDMA, and nowadays OFDM means orthogonal frequency division multiplexing is used. But if you are using non-orthogonal, so in non-orthogonal also a different kind of mechanisms are there. Like Noma, when you are combining with massive Noma, when you combine with code domain, power along with code, then a lot of advantages you can get. So these are the various types: IDMA, LDS, OFDM, then successive. See, this is IDMA is a interleaved division multiple access. LDS is low density spreading code division. So this particular spreading code is depend on the some spread spectrum based methodology. So here in the second method, as I told you, some hybrid strategy you can devise or you can create to improve the performance. Like if only power domain if we use, we can have certain disadvantages or limitations also. So to overcome that, we need to combine two approaches. So LDS along with CDMA can be used. Then the bit division multiplexing, multi-user shared access, the low density spreading, added orthogonal frequency division multiplexing. All these different techniques can be utilized to increase the or to just improve the performance of the non-orthogonal multiple access technique. So here, in 2015, Noma is accepted as a promising technology for 5G. So the work is a lot of work is going on since 2015, because then after a lot of advancements are advancements applied on the Noma technique, and then Noma is clubbed with a different other strategy or approaches for the efficient reception transmission of the system. In 5G, the MUST is known as a multi-user superposition transmission system in place of Noma. So when you are just searching on Google and specification of 5G, you may find this word MUST, which is nothing but reflecting ultimately the Noma technique. These are the some research issues. A lot of people is working on finding the ergodic capacity of this Noma technique, and how to reduce the SIC error when the one user is directly receiving, second is receiving through SIC, successive interference cancellation. So how SIC error can be reduced to other users. Then how to order this. For example, user number 1 is nearer, user number 2 is very far, third is not that much far but nearer. So in this way, how ordering need to be created, because it's not like that all the users are in proper order. User number 1 is nearer, user number 2 is 1 meter away, then user 2 is 2 meter away. It's not like that. It's not in a sequence sometimes, and it is mobile. It's a mobile network, so anybody's location can be changed anytime because of mobility. So in that case, how order changes are required. All these kind of challenges are there. Right, then ergodic, reducing the decoding latency, the speed, and here these are the real 5G use cases where the fifth generation wireless communication systems can be applicable. Right, this is the actual plan when the fifth generation was started. In 2000, that target is 2018-19. They tried to establish fixed wireless access, and it is already implemented. Right, we have seen in Airtel and Airtel has started in India just now, but in other countries, in the foreign countries, in South Korea, in many places, already this Wi-Fi zones, otherwise fixed wireless network already created on 5G, and they are using it. Then the target is in 2019, 20, and 21. We want to start the all mobile broadband with whatever 4G fallbacks are there to overcome that. We want to start, and it is also already working. In 2021-22, the massive MIMO, machine to machine, and IoT is the target. Still, the work is going on. Already, the Ericsson has started many their plants on 5th generation wireless communication system. That is, everything is wireless, and all the plant devices or machines are connected to the 5G technology, the 5G communication system. So it is also working in some industries. Now the work is going on ultra low latency IoT critical communication system. Critical communication, that means in some medical applications and in some very crucial or where the speed is very important for that application. Robust, reliable, and the low latency network we are trying to develop. These are the references that I have referred to prepare this presentation. And if you have any question, you can ask. Thank you very much, all of you. Now, if you have any question, you may raise.
Any questions?
Initially, I think voice is not means it's not audible. But then after, is it audible or not?
After that, it is okay, sir. There is no problem. Thank you very much, sir, for this wonderful lecture on 5G technology. Your talk is very informative and you have described everything, every concept in very proper way. And I hope all the participants have learned a lot about this latest technology. Thank you very much, sir. Now I request our second key speaker of this webinar, Dr. Jagdish Kumar Moonlal Rathod, for the expert talk. First of all, I would like to give brief introduction about the sir. He is currently working as an Associate Dean and Professor, COE, Electromagnetics and Antenna Research Center, Birla Vishwakarma Mahavidyalaya Engineering College, Vallabh Vidyanagar, Gujarat. He has completed his PhD in RF and wireless systems from Sardar Patel University, Gujarat in 2011 and Masters in Electronics and Communication Systems from DD University. Dr. Rathod is a recipient of Shiksha Bharati Award, Honor of Excellence in Research, Research Excellence Award, Academic Excellence Award by the various non-profit organizations. He has also received Academic Excellence Award 2 times by the Institute Gaurav Purskar in Individual Faculty Excellence category. He has organized several conferences, workshops, seminars, and training programs. He is guiding 10 PhD scholars and many students for their project developments. He has published 15 patents and several technical papers at international and national levels. He is also a member secretary of IEI and faculty advisor of IEEE Students Chapter. Now I request Rathod sir to please start your talk. Rathod sir, please. Sir, are you listening me? I think sir has joined, already joined, sir.
You are kindly called to the Rathod, sir.
Okay, sir, I can call him. Rathod sir, please.
Manpreet, they are joining.
Sir has already joined, but I have called. Sir, I have just called him, and he is already connected.
Okay.
It seems there is a problem with his audio. His microphone is on, but we can't hear him.
Rathore sir, are you hearing me?
No. 1 minute, please. Now. Hello.
Yes, sir.
Am I
Yes, sir,
audible?
you are audible.
Yes, sir.
Okay. Let me share the screen because I have some issues because I am right now as Dr. Manpreet Kaur is knowing about this, that I am at the out of station.
So you, yes, sir.
And I'm delivering this one. Thank you very
Yes,
much.
sir.
First of all, the IEI Batinda Center and Kolkata. I hope I am audible perfectly.
Yes, sir, you are perfectly audible and your screen is also visible. You can start it
Okay,
off
1
now.
minute. Please let me share my screen.
Yes, sir.
Yeah.
Excuse me, sir. You are connected from two devices. That is why we are having some echo. In the same place, you are connected with two devices. So we are having some echo problem for that.
Can you see this screen now?
Screen is visible, but there is echo for your
Screen is
voice.
visible.
Yes. But can you log out of one of the device? Hello. Hello.
Hello, Rathore sir. Hello.
Am I audible?
Yes, sir, you audible.
Thank you. Thank you. Thank you. I think voice is clear or not?
Now
This
it is
time
clear. Now it is
clear.
clear.
Thank you very much, sir. I'm apologized for this kind of delay and all. Let me share the screen. I hope you can see the screen right now, what I'm showing.
Yes, yes, sir. So your screen is visible, but your slides are not visible. Just please show your slides.
Let me.
So your slides are visible. You can start it off now. Rathore sir.
I think Sarah is having some audio problem.
Rathore sir.
Rathore, sir. Hello. Rathore, sir. Your audio is not coming. Manpreet, kindly call to Rathore sir. Manpreet. Manpreet.
Yes, sir. I'm calling him.
Okay, okay.
Okay, okay. So I think there is some kind of issue, network issue or some hearing problem.
ਮਨਪ੍ਰੀਤ ਉਹਨਾਂ ਨੂੰ ਕਾਲ ਕਰ ਲਿਆ ਸੀ ਹੈਲੋ ਹੈਲੋ
सर ने कॉल रिसीव नहीं की थी.
ਅੱਛਾ ਆਈ ਟੈਕਨੀਕਲ ਮੈਨੂੰ ਨੰਬਰ ਭੇਜ ਦਿਓ ਮੈਨੂੰ ਭੇਜੋ ਨੰਬਰ ਮਨਪ੍ਰੀਤ
Possibly he was using two gadgets, one for presentation and other one for audio. And I think he has locked out from audio gadget.
Hello, Dr. Rathore. Hello. Yes, Madam Manpreet Kaur.
Yes, sir. I just called him, but he's not receiving my call. I don't know what is the problem or what is the issue behind this. Whether some network issue or any other.
Grish sir what should be done
Sir, I think
Yes, sir.
I think Dr. Rathore is having some connectivity problem, audio connectivity problem.
Yes, we can move on, sir.
ਹਾਂਜੀ
We can move on to the next.
ਅੱਛਾ
I think we
should
have only
we
two,
start
I think we only have two panelists.
So we only have two panelists today.
Yeah.
Yes.
Have you
And
called?
can I start on antenna system
Yes, sir.
Yes, you can
Yes.
start.
I am
That
doing
will be
the
better because
slide.
our participants are there,
Yes.
so you
Yeah.
can start.
I will start on antenna system.
Yes, most welcome, sir. And thank you for such a alternative arrangement.
Thank you, sir.
रहमत रहमत ओ रहमत
Yes, sir. Jagtar sir.
Jikta sir.
हेलो
Yes.
Hello.
Yes, sir. Yes, Jagtar sir.
सर स्लाइड्स मुझे भी नहीं मिल रही एक्चुअली पीसी और है आई एम ट्राइंग सर इफ आई गॉट द स्लाइड्स आई विल स्टार्ट immediately
Else, can we keep this session tomorrow, sir?
Sir, if that
Yes, Sudeep sir.
tomorrow, sir, then participant has to, I have to create the link and participant has to register once again.
Okay.
That is possible, but then
Yeah.
I have to schedule it. If you decide accordingly, then I can schedule
Yeah,
anytime. If the second speaker is ready tomorrow,
yes,
then
second
we can.
speaker, we need to check availability of second speaker
Yeah.
or availability of another
I got
session.
the slide sir I am starting
Okay.
Okay. Okay, sir.
Respected Chairman, ETDB, and Dr. Tara Singh Kamal, I am starting microstrip patch antenna and artificial network approach for the design of microstrip patch antenna. So we will start. What is an antenna? Antenna is a device which converts the electrical signal into the electromagnetic wave. At the transmitter, at the receiver, it receives the electromagnetic waves and converts back into the electrical signal. So we can say antenna is a link between the transmitter and receiver. There are different types of antennas. We will discuss the microstrip patch antenna. It is the one of the most usable antenna at microwave frequencies. That is the frequency greater than 1 gigahertz. It usually consists of a metal patch on the ground plane and dielectric substrate. Patch may be variety of shapes. Rectangular and circular shapes are most common shapes. So here we have, this is the microstrip patch antenna with microstrip line feed, and it is made on Roger RT Droid material, and the other antenna is on FR4 glass epoxy material. So the most common shapes of microstrip patch antenna are rectangular, square, circular, elliptical, or annular ring, and triangular.
Jakhtar sir?
Why we go for the microstrip patch antenna?
Yes,
These
Jakhtar sir,
antennas are
please.
the low profile antennas.
Jakhtar sir, please.
The size of this antenna, these type of antenna is very, very small.
Jakhtar sir. Dr. Jakhtar sir, please.
Yes, sir.
Are you moving your slides, sir?
मेरी आवाज नहीं जा रही.
No, no, you are audible, but we see only the first slide.
अच्छा. कितने आवाज कितने? चक्की फोन. हाँ कर दे. इसके ऊपर स्टार्ट करेंगे. Most common shapes. Down slide. Can you see my slide, sir?
Yes,
Yes,
now.
sir.
Screen?
Yes,
Make
sir.
it full screen, sir.
Yeah, make it a full screen.
The most common shapes of microstrip patch antenna are rectangular, square, circular, annular ring, elliptical, and triangular. Why we go for the microstrip patch antenna? These antennas are the low profile antennas. These antennas are low profile antennas and flexible to conform to a surface, easy to fabricate. These type of antenna can be fabricated by a simple etching technique and easy to feed. These type of antenna can be easily feed the coaxial cable, microstrip line feed. These are the different types of feeding techniques by which we can feed the microstrip patch antenna. Easy to incorporate with other microstrip circuit element, as this antenna is the part of the part of the chip over which the antenna is designed. So this antenna is the part of the circuit. Patterns are somewhat hemispherical and moderate directivity, easy to use in array. The main disadvantage of microstrip patch antenna is less gain. The gain of antenna can be increased by using the group of antennas. The group of antennas used to increase the gain, that is known as the antenna array. Applications. These type of antenna can be used for satellite application, microwave communication application, cell phone antennas, and GPS antennas, global positioning system antennas. These are the group of antennas joined together to form the antenna array. This is the linear antenna array. This is 2:2 antenna array. This is 8:8 antenna array. And this is 4:8 antenna array. Next is the feeding techniques. The feeding techniques to the microstrip patch antennas are of two types. First is the contacting method. Second is the non-contacting method. In contacting method, the probe of the antenna is connected to the patch. So it is the microstrip line. Second is the coaxial line. And non-connecting methods are the aperture coupling and proximity coupling. This is the coaxial feed. Here the connector is connected through the substrate to the patch of the antenna, and other part of the connector is connected to the ground plane. The advantage of this technique is simple, compatible with coaxial cable, easy to obtain input match by adjusting the feed position. Disadvantage of this technique is there are some radiations from the thicker substrate. Significant probe inductance for thicker substrate, not easily compatible with the arrays. Next technique is inset feed. In case of inset feed, the feed is connected directly to the patch of the antenna. This method is also somewhat simple, allows for planar feeding, easy to use with arrays, easy to obtain the input match. The impedance can be matched by using this technique. The disadvantage is significant radiation from the thicker substrate. The next technique is proximity coupled technique, and next technique is the aperture coupled technique. These are the four techniques for feeding the microstrip patch antenna. When we design an antenna, the various steps for design the microstrip patch antenna is, first we calculate the width of the patch by using the frequency over which we want to operate. We calculate the width of the patch on the basis of dielectric constant of the material and resonant frequency of the antenna. The width of the patch is calculated. Then effective dielectric constant of the material is calculated. Then extension in length, that is delta L, is calculated. By substituting these values, we can calculate the length and the width of the patch, and with the help of IE3D simulator, or we can calculate the different parameters of microstrip patch antenna. The parameters for the microstrip patch antenna is the return loss. For return loss is the loss that is measure the effectiveness of the power delivery from the transmission line to a load. So for the such an antenna, the degree of mismatch the power between the incident and the reflected power in the traveling wave is denoted by incident power divided by the reflected power. The ratio of incident power to the reflected power, if we take the 10 log of this, then we get the return loss. Next is the voltage standing wave ratio. It is very important parameter in case of designing the antenna. If there is a impedance mismatching, then the transmitted wave and the reflected wave combines to each other to form the standing wave. The ratio of voltage maxima to the voltage minima is known as the voltage standing wave ratio. Where the voltage is maximum, the energy will get add up. Where the voltage is minimum, the energy will subtract to each other. So by using this formula, we can calculate the voltage standing wave ratio. For 100% matching, the standing wave ratio value should be equal to 1. So for antenna to be working at particular frequency, the value of voltage standing wave ratio should lie between 1 and 2. Next parameter is the bandwidth. Bandwidth is the range of frequency over which antenna works satisfactorily. The frequency over which antenna can work satisfactorily, that is known as the bandwidth. From this graph, return loss versus frequency plot, it is clear that as the frequency increases, return losses goes on decreasing. At particular frequency, the return losses becomes minimum, then again it starts increasing. The frequency at which the return losses becomes minus 10 dB in the lower part, then that is known as the lower cutoff frequency. Then it becomes minimum at the resonant frequency, then it starts increasing and again becomes minus 10 dB. That is known as the higher cutoff frequency. The difference between higher cutoff frequency and lower cutoff frequency, that is called bandwidth, over which an antenna can work satisfactorily. Then these are the some bandwidth observation, how we can increase the bandwidth of microstrip patch antenna. First is the bandwidth observation is for typical substrate having permittivity 2.2, the bandwidth is about 3%. By using the thick substrate, we can increase the bandwidth about 10%. By using the special feeding techniques and stacked patch, bandwidth can be achieved up to 100%. So next is the radiation efficiency, the ratio of radiated power to the total power supplied to an antenna, that is called radiation efficiency. The value of radiation efficiency lies between 0 to 1. 100% is in case of ideal case, which is not possible. The radiation efficiency is always less than 100% due to conductor loss, dielectric loss, surface wave excitation. This is the formula for radiation efficiency. Then improving the method for bandwidth of the microstrip patch antenna by using the U-shaped cut in the patch, we can increase the bandwidth of microstrip patch antenna up to 10 to 40%. 10 to 40% bandwidth can be increased by using the U-cut shape in the microstrip patch antenna, and it is reported in a paper that is published in the journal. Then by using double U slot, by using 2 U slots, the bandwidth can be increased up to 44%. Bandwidth is the limitation of microstrip patch antenna. The bandwidth of microstrip patch antenna is less. So we are discussing the different methods by which we can increase the bandwidth of microstrip patch antenna. Next method is by using a modification in U slot. A researcher has received a bandwidth of 34%, achieved a bandwidth of 34% by using probe inductance. So we designed this antenna, microstrip patch antenna, on a by using circular shape. We cut the 2 circular shapes from the circular at the diametric opposite edges. Then this antenna is fabricated, and this type of antenna is the monopole antenna. And this antenna is the results of this antenna is presented in the form of research paper in Wireless Personal Communication Journal. So next is the fractal antenna. What is an fractal? Fractal, it is a rough, broken or fragmented geometrical shape that can be split into the parts. A fractal antenna is an antenna that use the self-similar design to maximize the effective length or increase the perimeter of the material that can receive or transmit the electromagnetic radiations within a given total surface area or volume. Fractal antennas has two important properties. First is the space filling property. It leads to the decrease in the size of antenna. Second is the self-similar behavior. It helps in achieving the multi-band behavior of the antenna. Why we need the fractal antenna? If we see this diagram, the traditional antenna works at single frequency. This traditional triangular antenna works at one frequency, and green antenna works at other frequency, and yellow works at the third frequency, and blue one works at the fourth frequency. If we want to incorporate all four frequencies in a single antenna, then the solution is fractal antenna. In case of fractal antenna, a fractal antenna is an antenna which can work at the multiple frequencies, whereas the traditional patch antenna can work only single frequencies. So, types of fractal antenna. Generally the fractal geometries are divided into two categories. That is the random and the deterministic. Random means that the geometries that cannot be represented by the mathematical equations. That is known as the random fractals. Deterministic means those geometries that can be represented with the help of mathematical equations. That is known as the deterministic fractal. We have the Minkowski fractal antenna. This is the deterministic fractal because it can be represented with the help of mathematical equations. The originator in case of this is a straight line. The straight line is divided into three parts, and the central part is replaced by a square whose upper side is removed to get the Minkowski curve. By doing this, the perimeter of the wire increases in the same area. So antenna starts working at the lower frequency and miniaturization of the antenna takes place. Second is the Koch fractal. It is also the name of the Saiten's Koch. Here again we divided the originator curve into three parts, and the central part is replaced by a triangular curve. By using this, we can get the Koch fractal antenna. In case of Minkowski fractal antenna, we use the square shape. In case of Koch fractal antenna, we use the triangular geometry, and this process is repeated continuously to get other iterations of Koch fractal antenna. Then next is the Koch snowflake fractal antenna. In case of Koch snowflake antenna, we use the triangular geometry, and the Koch are applied at each side of the triangular geometry, and we get the snowflake-like structure. So the antenna is Koch snowflake fractal antenna. By using this method, by using the fractal, applying the fractal iterations at the sides of a triangle, we get the perimeter of the antenna increases, and antenna starts working at the lower frequency, and miniaturization of the antenna takes place. Next is the hybrid curve. In case of, if we are moving toward the hybrid fractal geometries. In case of hybrid curve, we join two or more curves to form a new curve that is known as the hybrid curve, which composes the both types of the which has the characteristics of both types of the curves. That is known as the hybrid curve. Here we use the Minkowski curve and inverted Minkowski curve. Minkowski and inverted Minkowski curve are joined together to form the modified Minkowski curve. And second, we taken the Hilbert curve. And this Minkowski curve is superimposed upon the Hilbert curve to get the Minkowski-Hilbert hybrid fractal antenna. By doing this type of processing, the perimeter of the antenna increases and length of the antenna in the same region gets increases, and antenna starts working toward the lower frequency, and antenna shows the multi-band behavior by using the fractal characteristics. So this, we have designed this antenna and published this research work in the form of a research paper, which is published in SCI Index Journal, AEUE, International Journal of Electronics and Communication Engineering. This antenna works at 12 frequencies. This antenna, so we can use this antenna up to 12 devices can be used to communicate by using this single antenna. Then again, we designed another antenna by using two Hilbert curves are joined to get the modified Hilbert, and this Hilbert curve is superimposed on the modified Minkowski curve to get the Hilbert-Minkowski hybrid fractal antenna. These both geometries are compared, and it is found that the Hilbert-Minkowski hybrid fractal antenna is better than the Minkowski-Hilbert fractal antenna. And this these results are available in the Journal of International Journal of Electronics and Communication Engineering. Again, another antenna is designed by us, by my student Karamjeet Kaur in the MTech thesis. She used Moore and Gosper curve for making the hybrid fractal antenna. Here is the Moore curve, and Gosper curve is superimposed on the Moore curve. In the same area, the perimeter of the antenna increases, and this antenna starts working at the 7 frequencies, and return losses values are minus 18.30, minus 16.10, and this paper is also published in a good journal, that is Wireless Personal Communication, in SCI Index Journal. Then Manpreet Kaur and Jagtar Singh Sivia both jointly done work on the Minkowski, Giuseppe piano and Koch curve. Here we used 3 curves: Minkowski, Giuseppe piano, and Koch curve. 3 curves are superimposed to get the hybrid curve, and artificial neural network technique has been used to design this antenna, and particle swarm optimization techniques has been used to optimizing the antenna, and this antenna can be used for the biomedical application. Ms. Manpreet Kaur has received on this topic the design of hybrid fractal antenna for biomedical application. So this paper is also published in the good journal, International Journal of Electronics and Communication Engineering, with good impact factor. Another we can use in, if we see the HFSS software, that when we design the antenna by using HFSS software, it becomes very difficult to make the antenna, drawing of the antenna. So there is a method. There is no need to draw the drawing in HFSS software. We can use the simple codes, IFS code, for designing the antenna. By writing the IFS, that is the mathematical equations, mathematical codes, but then by generating the BB scripting technique, and this these files are imported in simulator HFSS software, and we can get directly the shape of antenna without drawing the geometry of the antenna. So this is known as the IFS technique. IFS technique, in case of IFS, this is the mathematical method by which we can write the equations in case of IFS technique. The advantage of fractal antenna is because small in size, wide band and multi-band behavior shows good frequency range, reduced constructor cost, applications. The fractal antenna can be used in case of communication, wireless network, military application, and RFID applications. And then we can also use the artificial neural network for the design of antenna. Artificial neural networks work on the basis of the brain of a person. By learning process, artificial neural network is trained by using some input-output data. Then it starts predicting the different parameters of antenna. This technique is known as the artificial neural network. So artificial neural network can be used for predicting the resonant frequency of microstrip patch antenna or parameters of the antenna. Here we use the artificial neural network. Its pattern and connection between the neuron weights the learning algorithm on there. Its activation function is the mathematical source for decision making. These are the input layers. By applying the input, the neural network starts predicting output. This is the artificial neural network model. Here we applied the inputs that is multiplied by the weight and summation is done. Then activation function is applied to get the output. The types of artificial neural network, that is the feedback artificial neural network. When there is a output is given back to the input, that is known as the feedback artificial neural network. Then feed forward artificial neural network. Applications: simple identification and control, medical diagnosis, decision making. Artificial network can be used for modeling and design of the solar system generating plant. Artificial neural network can be used for the design of microstrip patch antenna. For training any artificial neural network, we have to generate a lot of data. There are two methods for generating the data. First is the measurement method, second is the simulation method. In case of measurement method, it is difficult. We have to design the different types of antenna. Then this antenna works at this frequency, and this process is complex. Simulation is simple. In case of simulation, we have to change the one or two parameters and we can get the output. So generally we use the simulation method for training the artificial neural network. For validation process, we use the measured results. This is the model of the artificial neural network. Here is input is given to the artificial neural network and output is taken and compared with the required output. If required output is not equal to the given output, then error is generated and weights are adjusted to get the actual output. So these are the here we designed the artificial neural network based model for predicting the design of antenna. On the design of a rectangular microstrip patch antenna using artificial neural network, here we applied the 15 algorithms for training the artificial neural network, and LM algorithm is found best algorithm for training the neural network. And this paper is published in the International Journal of Electronics and Telecommunication Engineering, IEI. Then we designed a calculator feed position of a rectangular microstrip patch antenna using artificial. Feed position is the most important parameter in case of microstrip patch antenna, where we have to apply the feed position. Feed position is a point we have to find where the impedance becomes equal to 50 ohm. So the position of the feed is changed to get the 50 ohm impedance. So the estimation of feed position of a rectangular microstrip patch antenna has been done by using artificial neural network. So I will not go in detail for the fractal antenna. Thank you very much. Any question from the for the antenna side. You can ask any question.
Any questions from the participants? Thank you very much, sir, for providing a useful lecture on antennas. Your talk is very informative and interesting, and your lecture is very beneficial to all, especially to the scholars who are working in antenna theory. Thank you very much, sir. Jitase. Now I request Engineer J.S. Deol, Honorary Secretary, Local Center, Bathinda, to propose a vote of thanks to the today's guest of event, Dr. Girish Sri Kisan Mundada, Dr. H.O. Thakre, and Dr. G. Ranganath, and our today's key speakers and the participants of the event. Engineer Deol, sir, please.
Thank you. May I speak?
Yes, sir.
Yes, sir. Just
Good evening to all. Myself, Honorary Secretary, J.S. Deol, Local Center, Bathinda. Thankful to our Chairman, Local Center, Bathinda, Dr. Jagtar Singh, CBI, for giving permission to organizing this event. I am also thankful to our key speaker, Dr. Ruthvi Si Joshi, Associate Professor and Head, ECE Department, PIET, Parallel University, Vadodara, Gujarat, and Dr. Jagdish Kumar Mohanlal Rathod. The second speaker was not available at this moment at this event due to link failure or say communication system missing. I am also thankful to Dr. H.O. Thakre, President, the Institution of Engineers India. I am also thankful to Professor Dr. Girish Sri Krishan Mundada, Chairman, Electronics and Telecommunication Engineering Division Board, IEI, sparing valuable time for us. I am also thankful to Dr. G. Ranganath, Chairman Committee for Advancement of Technology and Engineering, IE, for attending this event. I am also thankful to Dr. Manpreet Kaur, Assistant Professor, Yadavindra College of Engineering, Talwandi Sabo. Very special thanks to Professor and Dr. T.S. Kamal. I am also thankful to our committee, local center members, council members, corporate members, students, engineering fellow members for attending this event. Again, warm thanks to all.
thank you, sir. Thank you, Ji.
Thank you, sir.
Thank you, Dr. Girish.
Yes, thank you, Dr. Jagtar sir. Thank you, Dr. Kamal sir. Thank you, Deval sir. Thank you all speakers, participants, and our coordinator, Sudeep sir. Thank you.
Thank you, sir. Sir, with the permission of chair, can I end the webinar?